Hello everyone, welcome to our first video of the course Visualization Analytics. This is an introduction. Okay, so what is data visualization? Pretty much is a representation of data. Typically when you have thousands of hundreds of rows, you want to summarize data. And there are typically two strategies to summarize data. You can use tables or you can create some plots or charts. So that's one of the main reasons why we create some visualization, because we want to simplify complex data sets to be able to understand them better. Why? Because we want to identify patterns, trends. We want to detect whether there are some outliers or atypical data in all the tables that are in our databases. So typically you have used charts, graphs, maps, and different infographics. Those are examples of the ways in which you can visualize your data. Now, what is the importance of data visualization? Well, the idea is like once you identify patterns, it facilitates our decision making, so we can show to an audience, to decision makers, what are the insights. So because it's easier to analyze one plot, two plots, let's say 5 charts or 5 plots, instead of like using 100,000 observations. That's almost impossible for a human being to analyze unless you use visualization tools. So typically you will see applications in business. For sure, companies all the time, they are creating some charts to understand their sales, to understand their customers, the behavior of the customers, identify some patterns. So they use these visualizations on a daily basis, pretty much. In scientific research, in academia, you will see that in papers, in research papers, typically the results are presented using plots. When you want to compare two methods, you can use a box plot depending on the context. But visualization, for sure, it's an important tool in the academic context. In journalism, I'm pretty sure that every time you're watching the news or reading a newspaper or a book, you will see that they use charts to kind of like explain what's happening with something. For example, when they are talking about economical information, the unemployment rates, or inflation, so they want to see, the audience wants to see what is the trend, if it's growing or if it's decreasing, or if it's stable. Then they use charts to present that information instead of like they use saying information. It's more difficult to understand the words instead of having an image. Okay, so visualization analytics, where is located? So let me show you the data analysis studies. All the students that took the data analytics course last term, they are familiar with the data analysis studies. So the first one, this is the most basic data analysis that you can perform. It's a descriptive analysis. So in here, pretty much what you do is just find some, you're doing some counting. For example, let's talk about a census, the census. The information that you get initially, it's like, okay, number of people, the number of people per gender, or by ethnicity. So in the descriptive analysis, it's pretty much about just like some metrics. Now, the next step in that analysis, what follows, it's the exploratory data analysis, what we call the EDA. In the EDA, you go, like you get deeper in your data and you start understanding your data, and this is where you get some insights and you start asking questions. So the more you know about your data, so the more you can create some hypotheses. So you do this in the exploratory data analysis, and in this type of study, visualizations are a must. So most of the time you will use here time series, some plot, some bar charts, some lines, and different plots to be able to understand the relationship between two variables or among different variables. So charts are critical here in this step. So what I like to say always is like, even though most of you, I'm pretty sure that when you join a master in data science and analytics, the main interest of everyone is to make predictions and to find patterns, pattern identification. That's like the sexy part of data science. However, let me tell you, like most of the times, at least 99% of the time, you will do an EDA. This is more common, way more common, because companies all the time, they are doing EDA, all the time. When they have new data about their sales, about the inventory, like different type of data, the first thing that you do is an EDA to understand your data. So here you need good plots to be able to support, like what are the insights that you are finding, or the interesting question that you are asking. So that's why we need to learn data visualization properly, because it's gonna have a big impact in your skills as a data scientist. Then we have differential statistics. That's where we try to generalize based on a sample. So let's say that, for example, now that we're talking about the elections, there is a new president. So remember that during the election process and before the election process, there were a lot of polls. Every single day, every week, there was a new poll. So that's inferential analysis. So pretty much those companies, what they did is like they just take a sample, and based on that sample, they estimate what's going to be, like the voting percentage of the population, like the preferences of the people. So this is inferential analysis. It's just using a sample, try to generalize and draw some conclusions about the population of interest. The predictive analysis is where you want to predict a variable. So here we have regression models, classification models. In regression models is where you want to predict a numerical variable. Let's say that you want to predict the price of a house based on the different futures, or let's say that you're gonna you need a Uber or a Lyft because you want to go from point A to point B, but you want to estimate the fare. So that will depend on other variables like the weather, for example, the distance, how the traffic right now, day of the week. So you can use that information to make a prediction of the fare, right, the price, which is a numerical variable. In the classification problems, which are also predictive models, the Y variable is not numerical, it's categorical. For example, whether an email is a spam or not, if a person has a specific disease or not, or what level that person has of the disease. That's a classification problem. In banking, and let's say that bank can create a classification model for credit approval, to check whether a customer if it's okay to approve a specific loan or not. So that's a classification model. In all these stages, you can see visualization for sure. Most of the times in exploratory data analysis, in the predictive, for sure we'll use it to present results, especially when you want to show the importance of some variables in the prediction. Sometimes we use plots to highlight the importance. And the causal analysis, it's more to identify and you have full certainty that an X variable it's causing or has a direct impact in Y. So here typically you use design of experiments, DOE. That's the tool typically here to analyze this relationship between X and Y or among multiple X's and Y. So again, visualization for sure will be present here in EDA and in most of the studies, but the EDA heavily relies on visualization. So something that is important, it's a distinction between exploratory and explanatory, the explanation part. And this is a common mistake for the students and even data scientists that I have seen a lot. Typically, when you're doing like an exploratory data analysis and EDA, you want to show everything. I mean, you want to show to the audience like all the plots that you created, or to the professor, or all the work that you did, because it shows like that you were like your hard work, right? But the problem is at the end, what really matters is like when you're communicating, what's relevant is that you should show those key plots, those where really you can like tell most of the insights that you found. So a good analogy that is in one of the textbooks is it suggests that this process is like when you're trying to find pearls in oyster shells. So let's say that you need to check like 100 oyster shells to get only one or two pearls. So that that exploration is where you check like every single oyster, because some plots are, I mean, you won't find something interesting, and only in few of them you will find interesting insights. So that's the distinction between that exploration, that's when we're checking all the 100 shells, and that explanation is when we show the pearls, right? The nice part. Just this is a comment which is outside the topic. I was checking about the success rate when finding pearls in oysters. Actually, it's more difficult. It's not one or two in 100. It's more like one in 10,000. It's difficult to get a pearl naturally. So most of the time they cultivate pearls. There is a way in which, with human intervention, those pearls are created. Just a comment here. Okay. So a common mistakes that we do in data visualization, it's first, sometimes we overload with information our plots. So too many labels, too many colors, too many variables sometimes. So we gotta be careful with that. Misleading scales or labels. I will show you some examples with misleading scales. Poor color choices. Now you need to be aware like which colors can be like visualized easily. You need to consider the audience here. And this is what I was telling about the oysters and the pearls. So sometimes a common mistake is that you tell too many charts and few stories. Too many charts and few stories. And few good stories, right? Few insights. So it's not when you're doing data visualization, it's not about creating like a lot of plots or charts. It's more about like creating the right ones. Those that are going to make an impact in the understanding for the audience and decision makers. Okay, so let me show you some examples of common errors. So we have here four different plots. So the first one, it's a simple plot. It's just a bar chart. It was created using Excel. So it's comparing three categories, A, B, and C, right? And the values. So this is, let's say, a normal, an okay plot. The second chart, it says it's ugly. I mean, even though the information is fine, it's the same information that in the first one. The problem here is the color selection. Maybe if you keep looking at the chart, at least in my case, it's not, the colors are difficult for me to. They are like too shiny, too bright for me. At the same time, the grid, it's too dark. The grid here, the grid lines. Now we go to chart C. It's bad because if you notice, the y-axis is different, the scale is different for every single chart bar, and that's a problem. It's difficult to read, and it's not aligned. You see, here's the 2, and here is the 2, and here is the 2. It's not aligned, so it's difficult to see the differences. It's not recommended. So you are overcomplicating everything here in the chart number C. Now in the last one, in D, this one is wrong because there is no axis, the y-axis. We don't know the values, so the information is incomplete here. So it's difficult to follow. Okay, let's see some real examples. In the first one, here, newspaper was talking about like how big their sales are compared to their main competitors. So here's like the number of subscriptions, right, for them compared to the, like the second leading competitor. So when you see these charts here, the bar chart, there is like a huge difference. I mean, it can be misleading because someone might think that, okay, they have like almost twice the sales of the competitor, right? But then when you check the values, you see that the difference it's around 10%, right? The problem is like with the scale, with the units that they are using here in the y-axis, they are creating that delusion. So you will be careful when you are analyzing a plot or when you are creating a new one. So you need to be aware that these type of things can be misleading. Same problem is here in the second chart, where this was in the news. So they were talking about the tax rate. At some point, it was about to there was like a new a tax code that was about to expire. So if that occurred, then it's going to increase the tax rate from 35 to 39.6. So it's like a 4.6 points difference. But if you check the chart, it looks like it's going to jump, I don't know, like 3-4 times, like. So it kind of like, oh, I mean, they want to make a point for sure, but it can be misleading because the difference is not that high. Again, that's because of the y-axis. There are some books I have seen, like how to lie with statistics, or how lie with charts, and they have this type of examples. Okay, let me show you some before and after plots. So in this one, let me give you some context. So here it's about a company, and what they are doing is like they are comparing the number of orders that they get and how many of those orders they were able to process. It's pretty much to analyze like customer service, right? The service level. So I will give you, or you can pause the video only 10 seconds and try to understand what's happening here. And I'll tell you right away. So if you check initially, they were able to, to process all the orders, all the tickets, they got 160 and they were able to process 160. Again, in February, same thing, right? So they were like 100% service level. But then the numbers, you start seeing in June, for example, there is a difference between 161 and 150, same thing in July, and then you see a bigger gap in August from 202 to 156, right? So this is one way to present it. I mean, it's not wrong, but the problem is this is a time series. These are two time series. Those are values that they have a time stamp. So it's relevant to see the time for each observation. So typically you don't use bars to represent a time series. You use lines mainly. And now on top of that, this plot is giving us some context. So let's see. Initially, we see that the two variables, they are pretty much the same thing. So a good service level, but then in this specific point in May, there is where we start experiencing like a gap, and it increases. And now we have some context. 2 employees quit in May, so they were able to keep up with the income volume in the following 2 months, but then it was impossible. So look at it's the same information, but the second plot give us like a story, right? That's the storytelling part. Sometimes when we are talking about like data visualization analytics, people are expecting that we're gonna show like something huge, like a really special plot, and that's not required. What really matters is that we give insights. That's what we're doing here in this plot. It's a simple plot, like just a couple of lines, some text, but it's given the context and it's showing in a good way what's happening, right? This is a second example, similar to the previous one, but this one, it was worse because here we have 5 products, and we have the price for each product per year, right? We want to see like, okay, what's happening with the price, but it's difficult because there are a lot of years and a lot of products in this type of charts. It's difficult. Now with the lines, it's easier to see the pattern for each product, for the price of each product. So there is a recommended range, which now is included in the chart. So for decision makers, it's easier to see what's happening here. They have a clear picture here right away. But in the first plot, it was difficult. You needed to see each product individually. So for the first product, and then per year, it was a little bit difficult. But here, it's clear. Maybe you can change the colors for each line. That might be an alternative. So everything is about finding the right visualization, understanding what's the message that you wanna sell, right? At the end, what you wanna the decision makers and the audience to get from your analysis. So that here there are 6 principles for storytelling. These are like basic principles. So first, it's important to understand the context, to know what's happening, like in the example number 1, in the before after. The context was, okay, 2 employees they quitted their job, so that was important information, right? The context. Then choose an appropriate visual to display the information. For the time series, for example, bar charts are not appropriate, so it's better to use lines. So it's key to have, to have a good understanding when to use each type of plot. Eliminate the clutter. Focus attention where you want it. That's where we have annotation, some specific lines of reference. Think like a designer. I think that one is a little bit more difficult, depending of the background. And at the end, what matters is like you wanna tell a story. It's not about just showing plots and plots and plots. It's about showing a good plot or few plots, but with a good story to tell. That it's easy to follow, clear to understand, and you get to the main point. That's the whole idea of the storytelling. Now this is a common image to represent the process. So initially we do data collection, data preparation. So here everything is messy information. We create some visualization, visuals, some plots to understand our data. This is like the EDA, right? We do data analysis. So at this point, 3 and 4, like, in these steps, things are getting, you're getting like a better idea of what's happening. And then finally, you're able to tell the story, right? So that's what I want you to learn throughout this course. I want to give you the tools to prepare data, to start visualizing the data, creating multiple plots, and then we're going to analyze it and tell the story. That's pretty much the process that you're going to learn in this course. Okay, I'm going to stop this video for now. I'll see you in our next lecture.